Hello everyone, you are welcome once again to today's lesson, and in today's lesson we are going to look at the continuation of our previous lesson on vectors. So today's lesson will be lesson 3. In lesson 2 you realize that we dealt with certain types of vectors. We did equal vectors, we did what parallel vectors, okay, and some other types of vectors as well. Okay, however, in today's lesson we are going to look at the continuation of that, another type of what, of vectors. And just as you can see on your screens, we are going to first of all deal with perpendicular what, vectors. So you know the condition for two vectors to be parallel. Now for two vectors to be perpendicular, we must also know a certain condition or certain conditions. So quickly I read, two vectors are said to be perpendicular if, so we are going to look at these two conditions, but I will dwell much more on the second condition. Any of them will do. Okay, and I'll tell you why I will go for this. Okay, so if first of all, this condition, there is a rotation of 90 degrees or 270 degrees about the origin between them. Okay, so those of you who have done transformation in JHS, you know, you did reflection, rigid motions. You did reflection, rotation, enlargement, what have you. Okay, I'm talking about transformation in general. Okay, however, whenever you have two vectors and you realize that there exists a rotation of what's 90 degrees, okay, or 270 degrees, when we about the origin, remember rotation is usually done in which direction? Is it clockwise or anti-clockwise? Make your JHS teachers proud. Rotation, if you don't state the direction, if you don't state that it is clockwise or anti-clockwise, which direction are we looking at? My professors, you did
Oh,
you did what do you call it? Transformation in JHS, right?
yes, please.
So in JHS, you were told that usually rotation is done in which direction?
Clockwise.
In the clockwise direction. Okay, so it means if the direction is not specified, once you know your angle of what, rotation, and you know your center of rotation, which is what, about the origin, you should know that the direction is supposed to be what, clockwise, she said. So those of you don't know, go and find out whether it should be clockwise or anti-clockwise. Okay, so I'm not going to talk. And the reason why, okay, I'm not going to use the first one, okay, is because that one you need to know a certain formula or two formulas, one for 90 degrees rotation and one for 270 degrees rotation. In actual fact, it will be a mapping rule, okay, and you can consider that to be a formula as well. So we'll be looking at the second one. So all the product of their gradient is equal to -1. And here the more reason why we are going to rely on the second one is that we know from coordinate geometry, I've told you that vectors are closely linked, okay, connected to coordinate geometry. You can see that anytime I'm teaching, okay, I draw your attention to that, okay, that the two are connected. You know how to find a gradient of a line, any line, if it is not a directed the line segment. If you are asked to draw, find the gradient of any line. In coordinate geometry, we said that if I have the line AB, line AB, what will be, how do we find the gradient? We'll say that the gradient usually will be small m, and I told you that you can attach sub AB, meaning I'm finding the gradient of the line AB, so I'm more specific, and that will be equal to, what's the formula for finding the gradient? A quick one. Change in y over change in x, so it will be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Do you agree, my professors?
Yes, please.
And you remember we also did, okay, what do you call it? Perpendicular lines. So we said that for two lines to be parallel, when we were looking at lines, for two lines to be parallel, we said that their gradient should be the same. Is that not it?
F3.
So, and we said that for two lines to be perpendicular, the product of their gradient should give us -1, or the gradient should be negative reciprocal of each other. Do you remember?
F, please.
So after this, I intentionally left that one out. Okay, when we said we are dealing with perpendicular vectors, so we said for two vectors to be perpendicular, we can also use their gradients. So the product of their gradient should be -1. I want you to go back to the parallel and use that condition for two lines to be parallel. We said for two lines to be parallel, they should have the same gradient. So can we also say that for two vectors to be parallel, they should have the same gradient? So go back, okay, to the parallel one, use this information to check whether the line that gave us parallel, if you use that condition, sorry, did I say the lines? The vectors that gave us parallel, okay, conclusion. Check whether if you use the gradient, you end up drawing the same conclusion or otherwise. Take note. So I will not go back. Okay, this is just an assignment for you to do. Okay, so the gradient of what? We said the gradient of the two vectors, okay, the product should give us what? -1. So if let's say I have a vector, okay, AB, and I have another vector CD, okay, I can say that these two vectors are perpendicular, and I'm using, okay, the symbol for perpendicular. These two vectors are perpendicular if and only if, okay, the gradient of the vector AB, so small, you know, you use small m for gradient in geometry. So I'm using the vector AB. This time around, I've given AB a direction. Other than that, it will be the gradient of the line AB times the gradient of what? The vector CD, okay, should be equal to -1. Is that okay?
Yes, please.
Okay, now we know how to find the gradient of what? Lines. We don't know how to find the gradient of a vector, so that's the more reason why you have this short note here. So note, if you have a vector AB to be equal to x what? Y, then the gradient of what? AB will be equal to your y over x. In every vector, okay, your x here, okay, is already changing x, and your y here is already changing y. So your x component here has changing in it. Y component here has change, okay, in it. Please, do you agree with me, or I should demonstrate why that is the situation?
Yes, please.
Okay,
You
so
demonstrate.
even the formula will tell you we haven't done that. Okay, okay, we'll do that today. If I give you the vector AB and you want to use the point, you know that you do vector OB minus vector OA. Can you see that? I hope you are with me. We'll do this
Yes,
today, moving from a free vector to position vectors. We'll do that today. Okay, but every free vector in terms of position vectors will be the terminal, okay, point minus the initial point. And so the position vector of the terminal point, the position vector of the initial point. So assuming maybe my A, usually will say that let your point A be equal to x sub 1, y sub 1. And your point B will also be what? X sub 2, y sub 2. So point A, point B, I can say that this implies that my OA will be equal to this. Then my OB will be equal to this as well. I hope you agree with me, my professors.
yes, please.
Okay, so if I'm going to write my vector AB, let's see, my vector AB will be equal to x sub 2 minus y sub 2, then minus x sub 1, okay, y sub 1. Do you agree? Hello, do you agree?
Yes, please.
Okay, so which will be equal to, you know how to subtract vectors. So this will be x sub 2 minus x sub 1, then y sub 2 minus y sub 1. Is this not the same as changing x, changing y? You get it now. So every vector, once the values are stated, your S component, what you have there is in actual fact changing a certain S values, and your Y component that you have there will also be changing a certain Y values, which will be Y component. So take note of that. So if I say Y is equal to Y over X, then indirectly I'm trying to say that change in Y over change in X when you are dealing with vectors. Safa, all correct, my professors.
Yes, please.
Okay, so on that note, that takes us to our worked example under this type of vectors. Okay, so now let's see. Determine whether or not the following pairs of vectors are perpendicular. Okay, so as usual, we want to determine whether or not, so perpendicular, so we are determining perpendicularity. Okay, so solution, that's what you write first after reading the question and underlining the salient part. If your questions are normal, no major question normal, okay, so I come and write A. Okay, A, I extract the vectors that I'm giving. So giving my two vectors A, B, okay, which is equal to 1, 2, and your other vector CD, with component -2, 1. Okay, so with this 1, 2, we know for two vectors to be perpendicular, we need to state the condition. So let's state the condition and use the condition to guide us, just as we did in the, in the parallel situation. We will state our condition, which is the foundation of our argument, the premise. Then we'll use that to determine whatever that we want to. So perform our argument. So now what do we do for these two vectors, vector AB, to be perpendicular to vector CD? Okay, we know there is a condition. The gradient, so that is m, small m, of the vector AB, times, the gradient of the vector CD. Don't forget your arrow, must be equal to -1. Is my point well made, my professors?
Yes, please.
Yes,
Okay,
sir.
so as I've told you that these kind of questions are basically objective questions, but if it comes to subjective side, this is how you deal with it. In relative maths, we have a way of checking whether vectors are perpendicular. We don't do this. Okay, for us, we use the dot product, and Okay, so that's also another way. Okay, so now what do? We need to come and find the gradient of AB, then the gradient of CD. So I'm going to write the gradient of what? AB. So m sub AB, the vector AB, will be equal to, remember the gradient we said it is the y component over the s component. So that will give us 2/1. Do you agree? Okay, Prof. Ella.
So please, I wanted to ask, can you also find whether or not they are perpendicular by finding the dot product, summing the dot product of
Okay,
both of them by
I
this
said
product?
it. I just said it.
Oh, okay,
Please, did I
okay.
say it or I didn't?
You did, but
Yeah,
I
I
didn't really
did.
get it, so I
Okay, I
wanted
did.
to.
I did, but I said you can't do that here. That is relative math.
Okay.
What we are doing here, you can do it in relative math. But what we did in relative math, you can't do it in core math. That's the dot product. That's why I said in relative math, we have another way. Okay,
Oh,
we don't do dot product in core math. So you don't
Mr.
bring it here.
Hackman,
Yes, Prof. Abelema.
please, for vector AB to be perpendicular to vector C, please, the perpendicular sign, can you like write it somewhere else for me to see? Because I don't really know how to write it.
Okay. If perpendicular means the lines are meeting at an angle of 90, is that not it?
Yes.
Okay,
Okay,
so you have one line, another line, but usually because you use your free hand, okay, even if
okay,
you won't use your free hand and what do you call it, use a straight edge, it's possible that maybe as for this line, you can draw it through your lines in your book, so it will look horizontal. This might, okay, at least look diagonal a little. So to indicate that the angle here is that they are meeting at an angle of 90, we do this. That's all. So that even if you draw this one this way and the other one, okay, it's not a straight, then I mean it's this way, you do this, we still agree it is 90, not drawn to
Yes.
scale. You get the point?
Thank you so much.
You are
Yes,
welcome.
I do. Thank
All right, okay, you are welcome, my prof. So at this point, our M is going to give us what? 2. Do you agree? Professor, do you agree?
Yes, please.
Okay, all right. Please take note. I've advised you to avoid, okay, let me do it before somebody will come and tell me that I also did that. Okay, so I've told you to avoid writing more than 1 equal to on the same line. So this you come down and come and write your 2. Then, and your second gradient M, okay, CD, the gradient of the vector CD will be equal to, we said we are going to get y over the y component over the s component. What is the y component here? 1 over the s component, -2. You cannot end here. You don't leave a fraction, okay, with the negative in the denominator as your final answer. So this will be equal to, you bring the negative up, so -1 over 2. Is that clear?
Yes, sir.
Okay, so now we are going to write, okay, this. Okay, so I can now come and write, okay, so this implies that MAB, okay, times MCD, okay, will be equal to, don't forget your vector, will be equal to 2 times -1 on 2, which is equal to -1. Do you agree?
Yes.
Okay, so the condition, okay, for the 2 vectors to be perpendicular, is it satisfied?
Yes, please.
Okay, so you now come and write, therefore, please, okay, because I was for space, that's I wanted the whole of this thing to go here, but you can bring your -1 down here. Okay, the whole of this, you can bring it down. So you let me do that, because some of you likely, okay, would want to copy. So let me do the writing so that you also learn. So this, you come down, and s equal to, don't bring it here, bring it down. So this will simplify to -1. And you can see that on the implication line, okay, you can see equal to. So anytime you use implication, you either see on that line, you have to see equal to or inequality. So take note of that. Okay, so I can now say, therefore, what do we have? My line, a vector AB, okay, is what? Perpendicular to the vector CD. Okay, and if I comfortably attach my reason, my condition was satisfied. Okay, so therefore, okay, since MAB, okay, times what? The M of what? The vector CD, and it's a subs, okay, the CD is a sub, is equal to -1. Okay, Prof. Ma'am.
That please. You mentioned inequality. Please, what are you saying?
Okay, I was saying that you can see that I've told you that anytime you use the implication sign, it means where you have your implication sign, you should have equal to inequality sign, any of them. So it means this implication sign is valid because on that line I can see equal to there. You get it?
Yes.
Okay, but if I wrote implies that and brought this one down here, then there is a problem. You get it? Because where my implication is, there is no equal to on that line. So on that case, in that case, you have to cancel this and
Okay,
write
please.
maybe but, okay, something, but you cannot use the implication sign. Is that okay?
Yes.
Okay, all right. So that was just by the way anyway. So now let's go and let's do one more. My intention is to do only 2. Maybe one that is perpendicular and one that is not. Okay, okay, let me see. Okay, so I think this can go. Okay. My professors, I hope everyone is following, at least up to this point.
Yes, please.
Okay, wonderful.
Yes.
Okay, so now we are moving on to, okay, so let's do the B and C, maybe the last two before you. So B, again, you extract what you are giving. So what are we giving? We are giving two, okay, I mean pairs. So we are having what? PQ, the vector PQ is equal to the minus 2, 8, I'm right, yes. Okay, and the vector ST. Don't forget your arrow, very critical. Is equal to, okay, ST is minus 1, 4. Minus 1, 4. Okay, so now we state our condition. We know our vectors. We want to determine whether these two vectors are perpendicular, and we know we have to rely on what? On the gradient of the two vectors. So what do we write? Okay, so we know the condition for the vector PQ to be perpendicular to the vector ST. There is a condition. The product of their gradient should give us -1. So I'm going to get, okay, small m PQ, which is representing gradient of the line of vector PQ, okay, times the gradient of what? The vector ST, okay, should be equal to -1. Please take note, not 1, -1. So we know, how do we find this? Before we can find this side, you have to find this gradient, this gradient. Are they given? No. So we have to go and look for them. So, but, okay, the gradient of PQ, the vector PQ, will be equal to, remember we said it will be y over x. So your y component here is 8 over the s component, which is -2. So that gives us what? -4. Am I right, my professors?
Yes, sir.
Okay, and the second gradient. So small m of what? ST. Okay, will be equal to y component, which is 4, over the s component, which is -1. So this gives us, am I right? -4.
Yes.
Okay, so now you should know that these two gradients, you should know even before you multiply, that if you multiply, you won't get what? Negative what do you call it? 1. You will get 16. Can you see that? So they have the same gradient. Okay, so indirectly it's trying to tell you that the two vectors, this question that I asked you to, have answered the question for you indirectly. I've given you a head start. Okay, no problem. Okay, once the gradients are the same, it should tell you that they are parallel. Is that okay? And if you like, go and investigate whether the two vectors will be parallel or not using the old way where we use the k. Okay, so at this point, I am going to do, this implies that though I know, okay, so MPQ, or you also know now, times, okay, MST. Okay, I said you can do it mentally, will be equal to, so it will be -4 times -4, which it will be equal to what? Okay, 16, obviously not equal to -1. Okay, so now you know, therefore, you draw a conclusion. Okay, the two vectors, which will be PQ vector, okay, perpendicular will be this. So if it is not satisfied, what do? You cancel. Is that clear? It's the same thing. It's not perpendicular to the vector ST. My professors, I hope you are following. Okay,
Yes.
so since, okay, now you know what to write to. Okay, MPQ is not equal to, okay, ST. As simple as that. Sapa, Is my point well made? Who wants me to come again at this point? My professor, is my point well made?
Yes, please, but you've
Okay.
made a mistake.
I've made a mistake. Okay, where?
MPQ vector multiplying MST vector is not equal to -1.
This one.
Oh,
I,
the
I, I
conclusion.
wrote I wrote is equal to. Oh, I do get you. It wasn't intentional. Please forgive me. I do get you. In the conclusion, in the reason, that I assigned to my conclusion. Okay, so thank you very much. It wasn't intentional. Okay, in fact, it was a mistake. So you have every right to call it as such. So times your condition was this. So this is what you are supposed to. Okay, so ST. Okay, it's not equal to -1 rather. So that's how you draw your conclusion. Okay, Prof. Ama.
Mr. Hackman, so now that the conclusion has it's not equal to -1, is it necessary for us to still write the equal to 16 is not equal to -1?
Now, are you talking about here?
I said, are we saying the conclusion repeating the is equal to negative is not equal to -1? So is it necessary to write after multiplying the gradient is equal to
Is it necessary to
16,
write
which
the 16 before you write the not equal to -1? Do I get it right now?
is it necessary for you to write the is equal to negative? It is not equal to -1 beside the 16.
You mean here?
Yes.
Oh, here, the reason why I stated this is that you have a target. Okay, your target is to get -1. You get it? For you to say that, that's the more reason why I attached this. Okay, if you want to ignore, you can ignore because your condition, you've stated it here. So if it's not giving you, okay, -1, that's okay. But I wanted you to know that 16 is not equal to -1. Therefore, you draw the other conclusion. That's all.
Right.
Okay, all right. Okay, so I guess we are good to go. Let me see. Okay, with this, you should be able to do this, right? Only that this time around, the vectors are in the special notation for the position vectors, okay, form. So you argue in the same way. Only that here you write A tilde, don't forget your tilde, is perpendicular to, okay, B tilde, since, sorry, if, so let me write it here. Okay, so if you are supposed to perform your argument, that's just by the way. So I will extract my vector, so solution C, this, okay, given A, then I'll come and write for, okay, my vector A tilde to be perpendicular to my vector B tilde. Okay, I will get small m of A tilde, okay, then small m of A tilde, we said, okay, times small m of b tilde should be equal to what? -1. You come and find small m of a tilde, which will be the same as how you found the m here. So by inspection, what will be the m of a tilde? 3, right? This over this will give us 3. The negative will cancel. Okay, and what about this over this?
1
Okay, so 1 on 3. Will the product give you -1? No, the product will give you 1. So it means the vectors will not be perpendicular. You get the point? Okay, very good. My professors, are you with me?
Yes, please.
Okay, all right. So now let's move on to, okay, our next concept. After this, then maybe we can go for our water break. So we are dealing with types, still on types of vectors. Okay, and the next type will be negative or inverse, okay, vectors. Two vectors with the same magnitude but opposite in direction. Okay, so when you have two vectors with the same magnitude but they are moving in the opposite directions, okay, then we can say that the vectors are inverse vectors. Okay, therefore the negative or inverse of a vector AB, okay, is the vector BA, i.e. vector BA is equal to the negation of the vector AB. I know the relative math students, they have a fair idea of what we have here because I gave them a gist, okay, in one of the lessons. So basically this is it. If I have a vector, and you know that anytime you are dealing with a vector, you are moving from one point, okay, to another point. So I have the point A to the point B, but I'm moving in this direction. So that will give me my vector AB. Immediately I move from B to A, then you can see that now I'm walking in the opposite direction. So I can still have my A here, have my B, okay, and I'm linking these 2 points, okay, so I'm forming a line, but this time round I'm moving from here to here. So this will give me the vector BA. My initial point is A, my terminal point, sorry, is B, my terminal point is now what? A. Okay, these two vectors will have the same magnitude, but they are moving in the opposite direction. So if I move in this direction, if I do this, then I'm talking about BA. Okay, and they have the same magnitude, they are moving in the same, in the opposite direction. So we'll say that your vector BA is equal to the minus the vector AB. So if you know one vector, you know its inverse. How do you form the inverse? Just by multiplying the vector by negative. So I can also say that the vector AB, okay, is equal to minus the vector BA. So they are negatives, okay, of each other. So we have this negative or inverse, okay, vectors are also known as opposite or reverse what vectors. As simple as, so we can use these for interchangeably. Okay, opposite, inverse, negative, okay, and reverse. Is my point well made?
Yes.
Okay, as simple as that. So if you know one vector and you are asked to move in the opposite direction, which is the negative vector, what do? Just negate the vector. That's why I said negative vector. So negate the original vector and it will give you that vector. Okay, so take notes. So it means if I know the vector PQ, okay, and I'm asked to find the vector QP, you can see that I've swapped. Okay, so this will be equal to minus my known vector, which is vector PQ. As simple as that. Okay, so take note. So going forward, that's what we are going to do. So briefly, let's use, okay, the concept that we just learned here to deal with the questions that we have here. Maybe I'll do the first two and ask you to do the last two. Okay, so solution. Let's read the question. So you've been given 4, or in fact 5 vectors, A, B, B, C, C, D, then D, E. Okay, what are we supposed to do with these vectors? Okay, we are supposed to find, okay, vector AB. So as usual, solution, you extract your vectors. So I won't write all of them. Okay, so you extract the 5 vectors, that's 1, 2, 3. Okay, in actual fact, it's 4 vectors that we have there. Okay, then you come to A, what are we dealing with? Okay, the vector that I'm going to find is what I'll conclude with by experience. All right. Okay, therefore, vector BA, I know is equal to, okay, I know AB. So if I know AB and I'm asked to find BA, I don't need a point, okay, for the position vector of B, position vector of A. I know that BA will be the negation of what? AB. So this will be equal to, okay, minus my AB. What is my AB? AB is a vector 3, 2. Okay, so it means my BA will be equal to minus 3, minus 2. Is my point well made, or I should come again, my professors? Hello, my profs. Is my point well made?
Yes, sir.
Okay, very good. Then now, I had my conclusion drawn here. So my conclusion is embedded. Per experience, I knew that I would be concluding with this. Okay, so it's this which is equal to this. I could have brought this one down. as well. Okay, so maybe the next one, that's what I will do. Okay, so B, the last one. Therefore, what am I giving? The vector CB. That's what I'm asked to find. I know this will be equal to minus the vector BC because I know the vector BC. I know the CB. So that will be equal to minus, what is my vector BC? Vector BC is negative 4, okay, 1. Okay, so it means this will be equal to, okay, 4, negative 1. All correct, my professors. Hello, my professors.
Yes.
It's okay. So with that, I believe this will be trivial. So by inspection, okay, tell me the vector GC by inspection. The whole class. The vector GC will be, give me the answer straight
Negative.
away.
Negative 5.
Negative 5.
Negative 5. Positive 7.
So negative 5, okay, 7. You just multiply this vector by negative. And what will be the vector ED?
2, 3.
2, 3, as simple as that. Okay, so now I am convinced, okay, you are with me. Okay, so if that's the case, I guess we can go for our water break now. By 11:10, you should all be back. Okay, so your water break starts now. Okay, so welcome back from the water break. Now we are going to look at another, okay, type of, in fact, it's not, I'm not going to consider that as, okay, types of vectors, so we are not going to consider that as types of vectors. We are going to look at another concept related to what vectors, okay, and that will be resultant what vectors, okay, resultant vectors. Okay, so a resultant vector is the vector sum or combination of two or more individual vectors. Okay, so when you sum two or more vectors, we are dealing with what? Resultant vector. So your result will be a resultant vector, sort of. So it is obtained by adding two or more vectors, taking into account both the magnitude and the direction of the individual vectors. Okay, so briefly, let's see. Okay, so assuming maybe I'm moving from a point A, okay, to a point C, but I need to go through a point B. Okay, I can, maybe there is a rest stop here, let me put it that way. Okay, so I will move from the point A to the point B, then the point B to the point was C. But in all, I move from the point A to the point C. Do you agree? My professors, do you agree?
Yes.
Okay, so you can see that in getting to the point C from A, I had to move from A to B, which will give me my vector AB, then from B, okay, to C. But if I sum these two movements, that should give me my overall vector AC. That is my total distance, okay, covered, sort of, in that what direction. So what we have here is what will be, okay, the resultant vector. So it will be the resultant vector of these two vectors, the vector AB, okay, and the vector what, BC. However, here I considered, okay, a special situation where the points will be linear. Okay, in that case, we'll say that collinear, they will lie on the same line. But usually that will not be the situation. We have a more general situation that this is a special situation of. And that case will be, assuming I have 3 points, I'm moving from A to the point C, but I need to go through the point B. So it means I need to move from A to B, which will be given by this vector, and from B to C, which will be given by this vector. Now, professors, are you with me?
Yes.
Yes.
Okay, so if I move from A to B and B to C, you can see that overall I have moved from A towards C. So A to C, the direction will be this. I'm using, okay, 2 arrows to indicate or distinguish between these two so that this will will be regarded as what? As a resultant vector. So in the same way, whether my points are collinear or not, I can equally say from this diagram that my the vector AB plus the vector BC, okay, will give me my vector AC, which is the resultant vector. Is my point well made, my professors?
Yes.
Okay, very good. Okay, however, take note, in this situation, you should always know that the resultant vector, its arrow, will stop the flow of what? The other arrows, okay, of your two vectors. So you can see that this arrow and this arrow, they are in flow. Okay, the arrow here, you can see that they are moving. Okay, but this one is moving in the opposite direction, so it's stopping the flow, sort of. Please, should I come again, or my point is well made? So your resultant vector must always,
Please
okay,
come again.
yes, I said your resultant vector, its direction must always stop the flow of the other vectors that you are adding, you are combining its direction or their direction. So if I have maybe, again, let me use 3, I have, okay, this moving, let's say I have A, B, okay, C. Okay, let me do this. Okay, so vector BA plus the vector AC, these two are moving in the same direction. That should give me the vector BC. But you can see that the vector BC is opposing, okay, the already stopping the flow of what the two arrows. If the arrows will flow, then it means this arrow must be this way too, so that you see that the arrows will be flowing. Okay, but the resultant vector will stop the flow of the arrows. You get the point now?
Yes, please.
Okay, so take note. So immediately you realize that what you are taking as your resultant vector, its direction is not stopping the flow. You should know that there is something wrong. And again, whenever you are looking for your resultant vector, okay, especially when you are dealing with two vectors, the inner points, okay, must be the same, must coincide, and your outer point will give you your resultant what vector if you combine. So AC, so that's what you got here. Your resultant vector will be given by the outer point, but the inner point must always be the same. So in this case, if I have vector PQ, okay, plus what vector maybe ST, the only way I can say that vector PQ plus vector ST is equal to vector PT is when vector Q is equal to vector S. Other than that, okay, this cannot give me this. Should I come again?
Yes, please.
Okay, I said anytime you are adding vectors, okay, for you to get the resultant vector, okay, the inner vector point must be the same. If you look at these two, Q and S, they are not the same in terms of the letters, okay, the normal situation. So if you add PQ plus ST, you cannot get, on the face of it, you cannot get, okay, PT. The only way that you can get the vector PT will be when either the Q here is S or the S here is Q. So your inner point, okay, must be the same before you can say that the resultant will take the outer point. Is it clear now?
Yes,
Yes.
please.
Okay, so on that note, if let's say I have vector CD, okay, plus what? Okay, E, okay, will give me vector CE. What must be here before I can say that the resultant vector will be CE? What point must be here?
D.
D, perfect. Is my point well made now?
Yes, please.
Okay, very good.
Yes.
Okay, so if you get it, then we can quickly look at what, okay, this example. Okay, all right. So now let's see the worked example that will allow us to use the concept that we just learned okay, the direct concept about the resultant vectors, and we'll also use what? The inverse or negation vector at a point, because we now know. So where we need to fall on it, okay, we will fall on it. Okay, so let's see the question, the worked example. If vector A, B, so you've been given how many vectors? 4 vectors. Okay, so these are the vectors. A, B, B, C, C, D, D, E with their corresponding what? Components. What are we supposed to do? We are supposed to find the vector AC. So let's start solution. That's the first thing that we write. Is there anything for us to underline? No. So we go and extract. So given we extract the vectors. So I'm not going to extract. Okay, let me extract one, then do so that. Okay, so, but you cannot do this. You have to extract all of them. But I want to save time. So I will give in my vector AB, okay, is equal to 3, 2. Okay, then you go and state the rest of your vectors, comma, you continue. Okay, up to the last one, which is the DE. I hope I'm clear. You are with me. So you will extract everything. Because of time, okay, I'm going to move on to A. A, what are we supposed to find? We are supposed to find the vector AC. Okay, so now this will be my advice. As you mature, okay, you can choose not to, okay, draw exactly what I'm going to draw. But though our advice usually is better, okay, to do this, especially if you are not that matured. Okay, so here, if you look at the vectors, that the 4 vectors that we have here, how many distinct points can we mention? Vector A, B, B, C, C, D, D, E. How many points do you see in all the vectors that we have there? You know, vectors are made of points. So the first vector here, okay, how many points do you see in this vector?
2.
This one too, there is 2, but one is already catered for, which is the B. So it means you have an extra one, which is introduced C. So now in all we have 3. Do you agree?
Yes,
We
please.
have another one, 4.
again.
Then we have, I said, point. It will be, remember, points will form whenever you are dealing with vectors. You move from one point to another point, but in a specific direction. So I said every vector it will be made of 2 points. So this vector is made of the points A and B. This vector is made, okay, by the point C and what? B. But you can see that B is already in this. So it means I have 3 distinct points now, A, B, and C. Do you get it? If you come
Yes.
here 2 points C, D, but C has already been catered for, so there will be D, so 4. Okay, D has been catered for, so the extra one will be what? E. So it means we have how many? 5. Is that clear?
Yes.
Okay, so that gives us, what do we have? 5. So my advice is this is draw. Okay, guys, so let me see if I can squeeze that one here. So 1, 2, okay, 3, 4, okay, 5. Okay, so I'm going to call this the point A, point B, point C, point D, then point E. Okay, and I'm going to join A, B, B, C. You join with a straight edge, not a free hand. Okay, then C, D, then D, E. Okay, now A, B, follow the direction. That one is given. A, B, you know, it's given. In the question, B, C is also given. You know the direction. C, D is also given. Okay, then D, E is also given. So these are the original directions of your vectors, the known vectors in the question. Very critical. So that when you are opposing it, then you know that you are dealing with negative of a particular vector. Take note of that. Okay. Now, anytime you are finding resultant vectors where you've indicated the points, okay, you have to usually consider, okay, these two, either the shortest distance or the shortest route for you to move from your point A and get to, in this case, your point C, your final point to your terminal point. Okay, then 2, check whether, okay, you can go by the direction of what the original or go by the original direction in the questions. You will not oppose any direction stated in the question. So here, I know that I have a lot of routes to go. If I want to move from A to C, I can move from A to B, B to C. I can move from A to D, D to C. Still, I started from A, I ended at C. Okay, I can move from A to E, E to D, D to C. So I have a lot of routes to go. Okay, however, like I said, go for the shortest route, or the route that will not oppose any direction if possible. So here, if I take AB, BC, okay, I move twice, so maybe that will be one of the shortest, if not the shortest. And also, I didn't oppose any direction. So it means I know that my vector AC from the diagram here will be the vector AB plus what? The vector BC. My professors, are you following? So if I want to move from A to C, I'm using, okay, this will be and you can see that if you look at the direction of your AC arrows, it's stopping the flow of these two. So indeed, this will be the resultant when you add that. So this will be equal to AB. Do you know vector AB? Yes, I thank God I know vector AB. So that will give me 3, 2, as stated in the question. Plus my vector BC. Do I know BC directly? Yes, that is what? Minus what? 4, okay, 1. So now I know how to add vectors. So 3 plus minus 4 will give me minus 1. 2 plus 1 will give us what? 3. So I can write therefore, or I could have written that when I was going to sum. Therefore, my vector AC, okay, will be equal to this. Or now I know I'm smart. I know that I wouldn't change this. I can put my therefore here straight away. So going forward, that's how I will deal with it. I will let my conclusion be embedded in my presentation, just as I usually do when it is possible for me to do that. Okay, so please let's do one more. Okay, then after that, okay, I will give you opportunity to ask questions. Maybe after the second one, some of you will share your questions. So now I'll write therefore, okay, let's see, what do we have? AD. I'm looking for vector AD. Vector AD means I need to move from A to D. So A to D, I can move from A to B, B to C, then C to D. Do you agree? Hello, do you agree? We are going to play with, okay, the vectors that we've learned so far. Okay, please, my professors, you are not responding. Are you with me?
Yes,
Yes.
we are with you.
Okay,
Yes.
so now I can move from A to B, B to C, then C to D. So I'm going to write that this will be equal to, okay, vector AB plus what? Vector what? BC, then plus vector what? Help me. A to B, B to C, then what? C to D. Okay, very good. Okay, which will be equal to, okay, A to B. Okay, you follow the original direction, so you know AB. That is what? 3, 2. Okay, plus your vector BC. Your vector BC is also known. That is minus 4, 1. Then plus your vector CD. That is also known. 5, what? 7. Negative 7. Okay, so now this will be equal to, we can add everything at a go. Okay, Prof. Bliss. Mhm. Wow, yeah. Hello, your line is bad, Prof. Bliss. So if you can type, if you can hear me, okay, type and send that whatever that you want to say, okay, via the chat. Okay, so we are going to let's sum everything. So it will be 3, we sum corresponding component. 3 plus minus 4, which will give us minus 1. Okay, then plus what? 5, which will give us 4. Okay, then 2 plus 1, which is 3, then plus minus what? 7, which will give us what? Minus what? 4. Okay, so it means the vector AD will be equal to this. But take note, alternatively, we can handle it this way. Your vector AD will be equal to, I can say that it's equal to my vector AC plus my vector DC. So I can say that my vector AC, okay, plus my vector CD. Do you agree? Hello, do you agree?
Not yet.
Yes, please.
Did you say not yet? Okay,
Yeah.
so you have a lot of routes to go. If I want to get to C, sorry, D, I can move from A to C, okay, then C to D. This one you are just moving in any direction that you can move from A to E, then E, okay, to D. Okay. However, if you go this, I didn't join A and E, okay, because that was not given. I only joined the vectors that were given. So I didn't join this. Is that okay?
Yes, please.
So if you want to join, you can join. But if you join, can you give it any direction now? You can't give it any direction because it is not from the original. Prof. Blaze, I hope you get me now. So that's why I didn't join. Okay. All right. So this will be equal to, okay, AC, you have found it. Okay. So this time around, you are going to infer. Okay, you have found it. Even with this one, you know that this has AC in it, which is this. So I will infer, then get -1, 3, then plus my CD that was given, which is what, the 5, okay, -7. And you can see that if you combine these two, you end up getting the same result here. Safa,
Yes,
hello,
please.
is my point well made? Okay, very good. Now let's see how we can do the C. Okay, after the C, I think that will be it for, okay, this question. So the C, what are we looking for? We are looking for the vector CA. So I can say that therefore the vector CA. And here is by maturity that I know that I can draw my conclusion straight away. So the vector CA will be equal to, okay, I'm moving from C and I want to end at A. Okay, so C, and I want to end at A. I can do CD, then DA. Okay, I can also do CB and BA. Do you agree?
Yes,
So
please.
whichever direction that you take, you have to be very careful. Whichever route that you take, routes that you take, you have to be very careful. So I am going to go for, okay, B, C, B, sorry, okay, plus, okay, the vector BA. Okay, but I know this is equal to, do I know the vector CB? Okay, but you know that CB has the same magnitude as the vector BC, only that it is opposing it. So it will be the negation of this vector. Do you agree? Because I'm moving in the opposite direction. So the vector CB will be equal to minus the known vector BC. Is my point well made, Prophet Pierre Danson?
Please come again.
I should come again. Okay, any
Pastor
other question? Yes.
Peters, I wanted to ask if um you can apply the rule of the inverse.
Hold on, we'll do that. I've seen your plan, so you want to take the wind out of my sail. I won't mind you. Okay, we'll do that. Okay, we'll do that. But I want us to know how to play with the arrows. Then we'll go and look at the short one because we found, okay, one that can help us easily find it. Okay, all right. So can we continue, my professors?
Yes, please, we can,
Okay.
but please go back.
Yeah, I'll go over. No problem. I'll go over. Okay, so I said you are moving from C to A. So if I'm moving from C to A, I can move from C to B, then B to A. Do you agree? So any direction that you take, you have to be careful whether, so if I move from C to D, I'll ask myself, do I know the vector CD? Okay, I know. Okay, then I'll move from D to A. Do I know the vector DA? Okay, I don't know the vector DA. So it means I am supposed to go and find the vector DA. You get it? Before I can add it to the vector CD to give me my vector, what do you call it, DA. Do you get my point? So any direction that you take, ask yourself questions, whether you have vectors that you directly know or vectors that are closely linked to the known what vectors. And I said that, okay, I'm going to go by vector CB plus vector BA. Okay, Prof. Abelima, I thought maybe you allow me to finish, then you come.
Oh, Mr. Hackman, please, I have a very simple question.
Okay.
Please, me, I don't understand how vector CA equates to vector CB plus BA.
Oh, okay. So per what I told
Like
you,
the direction.
no, you per what I told you in terms of even resultant vectors. I told you that if you want to get your resultant vector, the outer vector, the outer vectors here will give you your result. The inner vectors must be the same. So if for nothing at all, you can see that this is possible. Someone can also write CA, okay, plus A. Oh no, once A is here, I cannot use A. So I can use C, maybe any other D, plus DA. You get it? From where we are coming from, the inner ones must be the same. You get it? Do you get it?
I don't get it.
Oh, all right, no problem. Okay, remember when we were doing resultant vectors, I asked you, you know the way I teach, you help me dealt with this. I said, what this will give us what? And he said, the outer vectors will be CE. So for CE, for us to get CE, then if I have CD, the other vector that I'm having here, its initial point should be the terminal point of this.
Oh, okay.
Tisamiti, I won't mind you. Jawasa.
Thank you.
You're welcome. So as for this one, if for nothing at all, you should relate with it because we said the inner vectors must be the same. So sorry, the inner point must be the same. And point indirectly, every point indirectly is a vector, position vector. So this must be the same. So that's why, like I said, you move from C to B, then B to A. Haven't you moved from C to A? Prof. Abelma, from the diagram, haven't you moved from C to A? If you move from C to B, then B to A, haven't you overall moved from C to A? Prof. Abelma, are you there? Can you hear me?
Mr. Hackman.
Yes. I said in the diagram that we have, if you move from C to B, then
Yes,
B to A, you have. And you can also move from C to D, then D to A. In all, you've moved from what C to what A.
Yes, please.
So you can take a whole lot of direction, but I said when you are taking the directions as or routes, ask yourself questions. Whether you have known vectors, are you going to go and find some other vectors before you can come and add? Okay, which indirectly will mean more work. So if you can go the route that will involve already given vectors or the vectors that are closely linked with the already given vectors, and that's what I did here. So this one, okay, CB plus BA. Okay, I am not giving vector CB directly, but I know that if I know vector BC, I know vector CB from the inverse or negation of vectors. Is that clear? Negative vectors. So I can say that this will be equal to, I know vector BC, okay, but I was not given vector CB. I know that vector CB will be the same as negation of vector BC. You get it?
Yes, please.
Okay, so then let's come to the vector BA. BA2, okay, you can see that, let me write plus here. Okay, I will not write a plus. So BA, okay, BA, if I'm moving from B to A, I'm opposing my original direction, okay, which is A to B. So that would be the negation of what? My original direction, A to B. Is that clear? Is my point well made? Okay,
Yes.
which in effect will be equal to, your vector minus your vector BC. Your vector BC, you know, that is given as -4, okay, the 1. Prof. Neil, please let me land, then, okay, I'll give you the opportunity, okay. Thanks for your understanding. Okay, then plus and minus, you know. Okay, so minus will override, so you get minus, okay, AB, your vector AB is what? Is 3, 2. Okay, which in effect will give us, okay, I'll push this one in. So I'm going to get, if I'm mature, you can even do it mentally. So I will get 4, -1 here, then minus what? 3, 2. So now I'm going to get 4 minus 3, which is what? Which is 1. Okay, then -1 minus 2, which will give us -3. Is my point well made?
Yes.
However, now that you know, and you even use negation vectors here, okay, or inverse of what? Of vectors here, we can equally find, okay, the CA straight away. So odds. Don't we know AC? We found AC in A. So once you know AC, you know CA, which will be the negation of AC. Do you get the point now?
Yes.
Okay, so that would be the ideal way, but I wanted us to play with the arrows and how to. So I can also say that, therefore, okay, let me calm down. Therefore, let me clear what you have there. Hey, yeah, this reminds me. Let me take care of that. So therefore, and please, okay, I've seen someone using this to represent therefore. Please, this and this are not the same. This one is therefore, and the first one is what? Is
Because
because you use this one to draw your conclusion. You use this one to add an information to your conclusion. Give a reason. Okay, take notes. You cannot use them interchangeably. Okay, so therefore your vector CA, okay, you know, will be equal to minus the vector AC, which you have found. If you have found it, then you come and do this. But if you have not, then you can go this route. So that will be equal to negation of your CA. And here I've told you, anytime you are inferring, you have to be sure that whatever that you are inferring from, okay, is correct. So that will give us, okay, 1, -3. Didn't we get the same thing? But this will be the matured way if you've done the AC. So it means if you've done AD, you can easily get the GA. Okay, and the last two will be yours. So this one you find the AE and use it to find the EA. You are not going to rely on any value that we have found. Okay, so you can try that on your own. Okay, Prof. Neil.
So please, it's fine.
It's fine. Okay, so I knew that maybe going forward, your issue would be addressed. Okay, so that would be it. Okay, for what we have here. Okay, so I think, all right, so expressing points as vectors. Okay, Prof. Matilda.
Mr. Hoffman.
Prof. Matilda, I'm
Please, can you hear me?
listening. Yeah, we are listening.
Please, is it necessary to bring the diagram in the presentation?
Oh, Prof. Matilda, I guess you are not listening to me. All right, I said usually the diagram is very helpful for you to know whether you are opposing certain direction, for you to use the negative or inverse of vectors. Otherwise, if you are matured, you can ignore. You get my point?
Yes, please.
Okay, so, but I will advise you to always, okay, plot, okay, and use it or draw the diagram. So if this happens to be your rough work, your diagram, when you are done, you strike it out. Okay, but do so in such a way that it will still be readable. Okay, so take notes of that. All right. Okay, Prof. Amma.
Mr. Hoffman, please, you said the alternative way is the ideal way. But Mr. Hoffman, what if the AC is wrong.
Okay, so that's why I said, before I said is the ideal way. Remember I said, in that case, you have to make sure that this is correct.
Okay.
You already know that you inferring will always make your work very easy. However, okay, sometimes shortcuts will be dangerous. It will be dangerous when whatever that you are inferring from is wrong. So before you infer, I always say that anytime I'm inferring, before you infer, make sure that what you have there is what correct. Other than that, to be garbage in, garbage out.
Okay, sir.
All right, you are welcome. Okay, so my professors, are we all fine?
Yes.
Okay, so very good. I wanted us to, okay, so I think I'm going to bring the curtains down here. Let me see. Oh, I think we can do, let's finish with the point end. Okay, so let's finish with that so that the next time we'll be looking at moving from, okay, well, the midpoint 2 is there. Okay, so I think I'll hold on. I'm going to end here, but no one should leave so that I'm going to, okay, do a certain exercise, okay, here for all of us, so no one should leave. All right, okay, so at this point, we are going to bring the curtains down on today's lesson. Okay, so thank you for your time and, okay, your attention. God bless us all.